次の発表はですね、Look what you made me do っていう発表で、レイチェル・ワイズさんから発表があります。で、レイチェルは、ラストイヤーも去年も来てくれてて、で去年も、去年はあれだな、IoT の発表かな、そんなしてくれてます。で、結構今回はデモが多めですごく楽しい発表だということなので期待してみてみましょう。じゃあ、拍手でお願いします。
Hello. Welcome to my talk. It is called Look What You MIDI Me Do. I'm going to start off by telling you a little bit about myself because it explains why I do the things that I do. My name's Rachel White, and I am the Developer Experience Lead at American Express, and I am also the former co-chair of the node.js Community Committee. So I really care about developers a lot and making their lives easier. Developer experience means that I help software engineers make a lot of the work that they're doing easier by enforcing better practices and collaboration, so enforcing CI/CD and good testing and trying to get rid of old bad code in general. And I'm also in charge of putting together our SDKs and monitoring the developer portal so that external developers can use our products. Previously, before switching to developer experience, I was a software engineer at Adobe, IBM, and Microsoft. And I switched to developer experience for a few reasons. The first one being, I don't like it when people tell me how to code. Two is, I'm not really that great of a programmer. Three is, I like to think of myself as more of a problem solver than a programmer. And four, to me personally, I think that code is art, and I really like to make things that are fun and exciting for people to experience. So aside from my job, I work on a lot of projects in my free time, and I like to consider myself a creative technologist because I like to blend creativity with programming. So whether that be hardware, making video games in the browser, doing live visuals, or trying to build things in virtual reality. I even had an artist residency last year where I got to blend art and special effects and hardware and Node.js. And so to get a picture of what that looks like, I will show it to you. So as a part of that artist residency I just mentioned, I created a series of artworks called New Romance, which is a play on the William Gibson book that's called Neuromancer, that a lot of people reference when talking about cyberpunk as a genre. And so I wanted to blend special effects makeup and hardware to visualize what modern cybernetic augmentation could look like. And so, as you can see, I made a mold of my friend's face, I cast it in silicone, I pigmented it to match their skin tone. Inside the silicone mold, I put a series of LED circuits that are connected to a control panel that are knobs that you can cycle through the RGB spectrum. And it's running Node.js on a Arduino. And it was really fun to make. There was also a copy of my hand that had a NeoPixel ring in it. This is my real hand holding my fake hand. And the light on the ring would light up if people were talking about my project on Twitter. Last year, I actually presented this project here at NodeFest. It is called Tiny Gallery, and it is a project that allows you to display pixel art, pixel art on a Raspberry Pi. And the pixel art is controlled from a website, so when you click on the art piece you want to display, it shows for a couple seconds. I also really love Gudetama, so I had to have him there. And that's also Node running on a Raspberry Pi. So the last thing that I want to tell you about is the one that is the most relevant to the talk today. And that's my experience performing as a visualist. So my VJ name is Miss Paint, which is a play on MS Paint, like the Microsoft software. And I've done a lot of visuals at chiptune shows as well as conferences like JSConf.eu. And I liked doing this, but the problem that I found was I was relying on tools that a lot of other people were making. I think there's a video of this with some audio so you can get a taste of it if it plays. That is the kind of visuals that I was doing previously. And I was using this software called Lumen, which is a digitalized version of old analog, video synths, complete with patch boards and different channels for knobs, and it was really cool, but the problem that I was having was it wasn't super adaptable to a lot of the things that I wanted to create, and it was hard to allow for other, input devices to overlay the patches that I made. And so I'll show you how this works a little bit right now really quickly. So as you can see, this is Lumen, and there are patches all along here, and there are different kinds of knobs that you can turn to create the different effects, and then you can save all of those and put them into presets. And then down here is kind of the only type of interface that you can have, which lets you scrub through the different devices. So while it looked really cool, it wasn't exactly what I was going for. So, yeah. So you might be thinking, okay, why would you want to build a visualizer when there are plenty of good options already out there? And like I mentioned before, I had already been doing this kind of work before I was relying on other people's tools. And I really love challenging myself to try things that I've never done before and don't really have any idea how to achieve the solution that I want. So my thought process is a little bit different than a typical engineer, I think, because I have a degree in graphic design. I'm just a really bad graphic designer, which is why I program. So what I do when I'm thinking of a project is I figure out how to put things together the hard way. So, for a robot that I built, instead of thinking of all of the technical aspects that I'm looking for, I would draw a picture of a button with an arrow to a light and just have it be turn on, and then break that down into how to achieve each step individually, and then figure out how to put it all together, which I guess is kind of a common thing. But the big thing with the visualizer that I wanted to build is I wanted to use external controls from the computer. I knew I wanted to use the browser, but I didn't want to use the keyboard on the laptop. I wanted to use a MIDI controller. So, MIDI is an acronym that stands for Musical Instrument Digital Interface, and it's a way to connect devices that make and control sound, such as synthesizers, samplers, and computers, so that they can communicate with each other using the MIDI messages. So, MIDI as a protocol allows electronic instruments and synthesizers to communicate, meaning a user can control multiple electronic instruments from one synthesizer or computer. And there used to be no coherent way for different manufacturers to have their machines interface with each other. So in 1981 at the Audio Engineering Society convention in New York, Dave Smith proposed a rough version of Universal Digital Interface that he called a Universal Synthesizer Interface, or USI. And he had a meeting for everyone that was interested in building the product the following year at the 1982 National Association of Music Merchants. And only a handful of people showed up, and among them was Mikotaro Kakahashi, who was the founder of Roland. And the following year, in 1983, at the next National Association of Music Merchants show, Dave Smith displayed the results of their collaborative work in a demonstration, and he connected Sequential Circuits, which was his company, their Prophet 600 synth, to Roland's Jupiter 6, and MIDI was born. And the work that they did together to work on this new protocol to allow different companies to be able to work collaboratively with their designs earned them a technical Grammy in 2013, which is pretty cool. Ooh, I need water and to breathe. 1 second. So, how does it work? So, the most important thing to understand about MIDI is that it's based on the idea of messages passing between devices. So, pieces of equipment or software. So you have a keyboard synthesizer and you want to record a sequence using sounds that are in the synth. You connect it to the computer and you connect the computer and synthesizer so that they can communicate using the MIDI protocol and start recording. So what happens? So when you play notes on the synthesizer, all of your physical actions, except maybe like you dancing to the music, are transmitted as MIDI messages to the computer sequencing software, which records the messages. And so MIDI isn't telling notes. It's just brief numeric descriptions of actions. So keys you press, knobs you turn, joystick stuff. Those are all encoded as MIDI messages. So you hear the sound that you're making, but the sound comes out of the synthesizer directly to your speakers. The computer doesn't record the sound itself. So the concept of channels is central to how most MIDI messages work. A channel is an independent path over which messages travel to their destination. And there are 16 channels per MIDI device. A track in your sequencer program plays one instrument over a single channel. And when dealing with the musical application, MIDI messages in the track find their way to the instrument over that channel. But we're not really dealing with music today, technically, because I don't understand how to read or write music, but we will be dealing with music, sort of. So we're going to be talking about the Web MIDI API. So MIDI typically enables synthesizers, keyboards, drum machines, or other controllers to communicate while being connected to their computer or device. But MIDI does not transmit audio, like I said. It sends event messages about music notes. So, we know how to handle events, so we should be able to handle input from MIDI. And it also uses controller signals for parameters, clock signals, and system-specific communications. And the same protocol is kind of a standard now for non-musical events like lighting at concerts and other special effects that you deal with, which is pretty cool, like fog machines, which I love. And so the Web MIDI API spec supports MIDI protocol by allowing web apps to enumerate and select MIDI input and output devices on the client system and send and receive MIDI messages. So by doing so, you're able to utilize non-music applications as well as music ones by providing low-level access to the MIDI devices on user systems. So people associate MIDI with the song files, which were really popular in like the 1990s. I think there was like a hamster dance site that you would go to and it would play MIDI files, and there's some karaoke that's MIDI karaoke when you want the real song and you don't get it. Sometimes it's sad. If you want to play music on the browser, that's not what the Web MIDI API is for. That would be the Web Audio API, or just use the audio tag for that. So the Web MIDI API is intended to enable direct access to devices that respond to MIDI, so controllers, external synthesizers, or lighting systems. And it's designed to allow web applications that respond to MIDI controller inputs using external hardware controllers with physical interactions and musical controllers as well. And the Web MIDI API is also expected to be used in conjunction with other APIs, like the Web Audio API, if you wanted to make a synthesizer in the browser. So if you want to use the Web MIDI API, you should probably be using Chrome. Chrome 43 or higher, some Opera, some Android, but that's kind of it. So I wanted to show you some Web MIDI demos right now. So let me drag this over. I'm going to switch the display to mirror temporarily. Is that okay? I think it should be fine, right? Let's see. We'll see when we get there. All right, so this is just how the Web MIDI API works. So you call request MIDI access on Navigator, and the top thing in the console is just a comment that I left on the actual page. So if you do have Web MIDI enabled in your browser, you can console log this browser supports Web MIDI. If you don't, then it'll say it is not supported. Ooh, hold on, we don't want full screen. We want a little bit bigger than that. Ignore Twitter. All right, so the second thing is, handling the object that gets returned when you push buttons. So in addition to requesting MIDI access, you can console log the parameters that are coming back through it, and it logs all of the available inputs. So I have a MIDI controller plugged in to my computer right here, so I can open it and know that I have inputs available to me, I have outputs available to me. Now I'm ready to use them. But the other thing that is really important is you need to be able to, iterate through the object when you get messages. The MIDI controller that I am specifically using has arcade buttons on it, and it also has velocity, so it has a potentiometer inside, so you can tilt it and add it around, which I'll show you really quick. Makes a whole big mess when you are trying to log simple data, but if I clear that, I'm able to push a button, and it logs typically, I'll push it gentler. Okay, it logs the messages for pushing and releasing. And then when you open it up, you can see this array right here, which is the important information that we want. It's talking about the channels and the specific ID of the buttons that we're pressing. So the majority of the project that I'm going to be showing you today is just parsing that data that's coming in. So this does have audio, so we'll see if it works. All right, so everybody knows Mario Paint, hopefully. This is a version that Leah Rosema made of Music Paint. It is enabled through the MIDI controller, so, oops. 1 second. Okay, I'm going to refresh this so I can use my buttons. I told you I don't know music. I'm not showing you it yet because it'll be exciting in a minute. Oh, okay. I'll show you. So, alone, this MIDI controller is exciting to look at too when you're pushing the buttons. So that's part of the reason that I wanted to build it. Another guy gave a really awesome talk at JSConf US this year where he built his own tooling to be able to do visuals. I don't even understand half of the stuff that's happening here. It's just so impressive. So this one particularly, I'm able to, oops, I should close this so it's quiet now. So this one in specific, I'm able to push the buttons and it plays the little drums, which is really cute. For the project that I'm going to show you today, I am using the Web MIDI API shim because it was easy. You can, embed it, and also I bothered the guy that made it, so he helped me, which is always fun for when you're doing projects. All right, so let me go back to mirroring, or using a separate display. And, okay. So, I decided to name my project Vidi, because I'm not that clever. And so, when I originally started this project, if you read the description on the conference site, I was like, yeah, we're going to use WebGL shaders and make it really intense. But it turns out that shaders are really hard to use. So I was a little bit overambitious, and I decided to take an open source project by this guy who I am mutual friends with online called PixelSynth. So that was easy. I didn't have to write any shaders yet. I just used the canvas animations and built on those. So, like I told you before, the MIDI controller that I wanted to use to specifically control that is this. It's called the MIDI Fighter 3D. So when you tilt it, oh, I hit the HDMI again. I'm sorry. You fix that and I'll show them lights. So you can see it changes colors as I tilt it based off of the direction that it's being used. And also, when it's flatter, it radiates colors from each of the buttons. There's also buttons on the side, and each of these 4 at the top are different banks. So you get 16 per one that you're able to use. We'll go back to that one. So this is full color configurable arcade buttons, and it's got total motion on all 3 axes. And so I wanted to take advantage of this because of the Till library. People don't really use this that much for visuals. I've seen it be used as an actual arcade thing, but the thing that this controller is specifically more famous for is finger drumming, which I'll show you what it looks like.
Please enjoy.
Not going to play the whole thing. So that is when you're using the controller with Ableton or Tractor and mapping it to your own music. You can do a lot of really interesting stuff. So now I'm going to show you MIDI. I have a warning here, which is that if you are offended by badly written code that needs to be refactored and converted to ES6, please close your eyes. Okay. I'm going to go back to mirroring. Alright, so basically I'm kind of cheating. I know this is NodeFest and I am using Node, but it's pretty much just using Node to route to the HTML file with the plain JavaScript that is linked in a script tag. I do want to convert this to being mostly on the server side, but it was hard enough to figure out how to get all of this work done. I'm not going to explain this line for line. I'm just going to kind of give you an idea of what it looks like. So this is the navigator that we were referring to, and inside there is just a lot of mapping of the buttons, error handling, some helper functions that are letting me figure out math, and then the function that is constructing the actual synthesizer. The visual synthesizer that is going to be a canvas animation. And there's 4 different waves, and they all have different values. This is what they look like at their default, and then it automatically sizes it and determines the pixel size based off of the initial page load. And then I have a randomizer. I don't know why that's an arrow function, but I'll deal with it. And then I just have, all of the different synth waves in there mapped to different names, and then randomizing the background and foreground, and initializing the synth, cleaning up some parameters because figuring out how to get a median value from tilting the axis on this was probably the hardest part of this whole entire project. You can see right here, I am looking at the channel that is coming in through the values, so 147, 146, 179, those handle different buttons that are being pressed. And then this one is finding the middle point for scaling and rotating the canvas. The way that I initially had this written is, so there's 16 buttons on here. I'm using 8, 16, 24 of the buttons. My first pass before I refactored a little bit was a switch statement for each button, and that was a mess, so I then switched it over to, if I can open it, I will show you. I made just an object so I could iterate over each button and know the value for each one that it had. So it was easier to use that way. And then down at the bottom, it's just draw. So I think the next thing is I'm going to actually give you a demo of how it works, because even though you've probably been seeing the back of all these slides are pretty cool graphics, you might want to go to the volume right now. So yeah, I'm going to give you a demo of what it looks like when I would do this live at a show. And since it is a canvas animation, there is some weird scaling sometimes, but if there was a version that was like before alpha, then that is what this would be. So I hope you enjoy it. Thank you. So, yeah, the future would be, I would love to have custom MIDI mapping so that users are able to plug in whatever device that they like to use, push a few buttons, and map those to the visual library of their choosing. And I would love for there to be support beyond the canvas animations that Donald Hansen created with PixelSynth. I would love to add in WebGL shaders, P5 animations, 3JS animations, and even CSS animations would be really rad. But I guess I have to learn how to do that. Maybe that'll be another talk. So here are resources to a lot of my research for this talk, including the WebMIDI API shim, the actual API specs, some history of MIDI, code pens that I demoed, and I don't have a link to Vidi, but if you tweet at me at OHO, I can send it to you, as long as you promise not to make fun of me, and I am like right on time. Thank you.
スーパークールじゃないですか。すごくないですか。ちょっとなんか表現できないです。言葉では。すごいスーパークールでした。次の発表いきましょうか。次の発表は。